Hey everybody, it's Erik, co-founder, partner of Village Global, a network-driven venture firm. And this is Venture Stories, a podcast covering topics relating to tech and business with world-leading experts. Hey everybody, welcome to another episode of Village Global's Venture Stories Web3 edition. I'm here today joined by special returning guest, Joel Monegro of Placeholder. Joel, welcome back to the program.
Erik, it's a pleasure. Thank you for having me.
So Joel, you're a Placeholder 2. In 2018, you released the Placeholder thesis. You talked about you were excited about infrastructure protocols, decentralized apps, user interfaces. Obviously, crypto years are like dog years in that a lot has changed over the past few years. Why don't you give a high-level overview of when you started Placeholder, what you were excited to invest in and how you saw the space, and how, as the space has evolved, your firm and your thesis has evolved alongside with it in terms of if you published a new version of that thesis today, what might stay the same and what might be different?
Great. So we're going to be talking for a while, but that'll be an interesting exploration. It's kind of going back in time, even before Placeholder and more of the times when I was at Union Square Ventures. The initial fascination with blockchains back in the 2014, 15, 16 era was mostly focused on just how different the data structure is on a blockchain-based system versus the traditional server-based architectures that we have in Web 2 and so on. And back then, we pretty much only had Bitcoin and a bunch of Bitcoin forks that didn't differentiate all that much from BTC. And we had a bunch of ideas, but something that was clear was that this is a network where the data is stored in the network itself as opposed to the applications on top. And so it took a while for us to kind of work through and think through that idea and all the implications. And over the years, over that period, that was mainly the focus. And we didn't quite know how it was going to be monetized. We didn't quite know how the investment opportunities were going to materialize. And it was actually quite difficult to think about those problems because we were coming from a mental model where the defensibility of a digital services business came from its ownership of data. And regardless, we made some seed investments in companies that were playing with these new ideas, and not many of them worked out. Some did, but we learned a lot in that process. And this is still the pre-token era. I mean, we had crypto assets in the form of Bitcoin, et cetera, but we didn't have the concept of a token per se. Ethereum hadn't launched or was still in development, and so it was quite early. And then after the Ethereum kind of launched, that brought one of the first smart contract networks, and people started building on top of blockchains more directly with smart contracts specifically, then the scope broadened a bit, or by quite a lot, because we started to understand how the tokenization of assets and the ability to create digital assets can actually solve some of the challenges that we were thinking about in terms of creating business models around open source data. And so around the time that we started Placeholder was around the time when we were starting to make that transition into thinking and really deeply understanding the different ways in which digital assets fundamentally are extremely useful. And this was mostly possible, or at least it was easier for me to think about it once programmability came to blockchains, again, kind of spearheaded by Ethereum. And so at that time, when we were starting Placeholder, I was most focused on just the effects of tokenization. And so I really went back and kind of restudied the history of financial assets and how they came about, and came upon this insight that really most financial assets, if not every financial asset out there, is a contract between two or more people. And so in those contracts create entries on a ledger, for example. And that's how the world and the economy works today. We have legal contracts and we have entries on ledgers, usually say, the balance sheet of a company or things like that. And then now in the blockchain world, we have smart contracts, which are contracts written in code. And then we also have entries on a ledger. But in this case, the ledger is the blockchain as opposed to, private books or counterparties and things like that. And so that idea is really the one that broadened the scope out from focusing purely on open source data and focusing more on, okay, we actually have these new mechanisms, smart contracts and tokens on top of blockchains, on top of open source data that allows for some very interesting innovations. And so that's when I at least started thinking a little bit more about the assets that were being created on top, not just the data itself, and kind of realizing, okay, the base layer of information that exists on chain is an input to smart contracts that create new kinds of assets, new kinds of digital assets. And so that became to me the biggest idea, at least as far as I'm concerned, probably the biggest idea in the world. When we started investing in 2017, 18, and 19, a lot of our early investments were based on building the new infrastructure for digital, a world full of digital assets. And so a lot of what we did was base layer blockchain protocols, but we also did quite a lot of decentralized finance with the understanding that with an explosion of digital assets, we were also going to need a financial system for those digital assets, and that could only come from the space itself, kind of a native financial system. And so that's how we spent a lot of 2018 and 2019. We kind of saw the base platforms, developer tools, smart contract platforms and services and DeFi as the kind of layer of infrastructure for what was to come. But we weren't exactly sure what was to come. And so then what we started seeing over the past couple of years is more innovations around decentralized organizations or DAOs, which is something that we've always been quite interested in. And more recently, everything that's been going on with NFTs. And so we're beginning now to see exactly what kinds of products, services, economies, worlds are being created on top of that infrastructure that started emerging in the 2014 to 2020 era. And now that we're entering another market cycle, I think it's going to be really interesting to see what gets built over the next 2 years now that we have a solid base of infrastructure, which we really didn't have 4, 5, 6 years ago.
And say more about what that infrastructure is and what you think that could enable.
So starting from the bottom, crypto likes to think in terms of layers, which can sometimes be helpful. And so at the bottommost layer, you have blockchains of different kinds. And now we have many of them, and they have different features and different trade-offs that they make and how they operate. Many of them, or if not all of them, are trending towards programmability, being platforms for developers to write software on top of. And what the blockchain does is it provides this decentralized or ideally decentralized ledger of all of the transactions and all of the operations that happen on top of the network. And what that allows for is for the software that's built on a blockchain to be aware of every other software that's built on the same blockchain. And so, for example, on Ethereum, if I write a smart contract, which is essentially software on top of the Ethereum platform, I am not only aware of the data and the information that my software creates and manipulates, I am also aware of all the data and all the software that is also running on the Ethereum network. And so that gives me a lot of visibility as an application or as an application developer. And it enables something called composability, which is the ability for separate independent pieces of software to be aware of one another and to talk to each other. And so that's pretty similar to what we have in Web 2 in terms of APIs, where right now, most of Web 2 is probably reliant on several APIs, and there's a real kind of network that's created where, every time an application sends a text message, it probably uses the Twilio API, for example, or if it's going to store some files, it probably uses the Amazon S3 API. And so it's a familiar concept. The difference being that in the API world, all of the APIs are kind of being provided by a distinct company that has control over that API. And so if Amazon goes down or Amazon closes my account for some reason, I could lose access to my infrastructure as a developer or as an application. And same for all the other APIs that are used. Whereas on chain, once a smart contract is deployed, it can't really be taken back. It's really permanent. And so in most cases, or at least a big part of the mantra or belief system of crypto is that you write these services as smart contracts. And those smart contracts are openly available to anyone else on the network who wants to use them. And they're usually built in a way that not even the developers have control over it and can't even shut it down. And so already we start to see some pretty important differences just at the base layer of the stack, so to speak, where in Web 2, you have software services delivered via servers controlled by companies. In Web 3, you have smart contract-based services delivered by networks and controlled by communities. And so just picking on controlled by communities to move up a layer, what ends up being written as smart contracts is actually quite interesting because it's very different from what you can build on, say, the Amazon Compute Cloud or traditional servers. You don't quite build and deploy full applications on a chain, in part because it's quite expensive, in part because chains are actually quite slow. Even the fastest ones really can't match the speed of a completely centralized service. And so what ends up happening is that if you want to build a complex application, you first have to figure out how much of that application can be written as a smart contract and how much has to be written sort of off chain is the term. And so you kind of figure out, okay, what's essential to have on chain based on the qualities that on chain provides, like permanence of information, reliability, availability of the information, making sure that access can't be shut off. And then what are the things that doesn't make sense or are not necessary to have on chain? And then you can kind of build those in a separate way or put them in a traditional server, et cetera. And so what you can actually build on chain, or at least so far, what we've been able to put on chain are things like tokens. So the creation of digital assets and the rules around how those tokens behave, the rules around transfers, the quantity of those tokens, supply and things like that. And we've been able to do things like NFTs, which are a different kind of token. And so we can create digital assets, those go on chain, and we can create code that manipulates the rules of those digital assets. And then, some other thing that we can build that are quite interesting is we can also build smart contracts that are, some smart contracts create assets, but other smart contracts can govern other things. So one of the things I'm most interested in is how people are creating digital organizations based on smart contracts. And these would be DAOs or decentralized autonomous organizations. And those are really governance systems for communities where once you've created a digital asset, for example, you can create a voting system or a governance system where you use that digital asset, if you're the holder of it, as a way to express a vote or express an opinion. And a lot of what people have been building on top of blockchains is governed by DAOs, where you might create a protocol, you might create a network or a service. Let's say something like Uniswap, which is a decentralized exchange. And what Uniswap did is they created a DAO and they created a token called Uni. And every token holder can vote on the DAO. And the core developers of the software have basically committed to following the direction that the DAO sets. And through that mechanism, they've created a way for the community to have an influence over the overall direction of the project and the software. And that's a very high level kind of simplistic explanation. But the core ideas here are on chain, you can create digital assets and you can create rules around how those digital assets behave, who can have them, who can't have them, what are the rules around creation, around distribution. And what you have with those two components is the ability to create more complex kind of networks and systems like DAOs or different kinds of services. And so those are the things that go on chain. One thing that's kind of interesting about this architecture is a lot of what ends up being created looks quite similar to what you see, say, with a company, where and a lot of the kind of controversy around crypto has to do with this effect, where in some cases tokens in a DAO can be very similar to, say, equity in a company, if you think about it. And this was one of the kind of other big ideas that I couldn't stop thinking about. And it's that once you've kind of put all these pieces together, a DAO can look a lot like a company or a lot like a traditional organization, and it can have, income and losses and generate profits and things like that. And a lot of the same kind of needs and requirements emerge when it comes to managing a DAO. But the big difference is with a DAO or with digital organizations, if the base asset, if the controlling asset is a digital asset, you actually have a lot more flexibility around how you distribute ownership and control. When you have a private equity company, shares of stock are actually quite difficult to transfer and move around. And you have a lot of flexibility to define how the shares are created, distributed, what powers they have and what they don't, similar to how you have that power with code and tokens. But it's really quite hard for you to say, give a share of stock of your company to somebody in Singapore. It's really quite complex and really quite difficult. And so there's this kind of interesting dynamic between equity-based organizations and smart contract-based organizations, where smart contract-based organizations have the power to have a much more broadly distributed base of owners than a centralized company, purely by the fact that they run on code on decentralized blockchains as opposed to running within the jurisdiction of a country or a state.
Totally. No, that's a great exposition. There's a lot of follow-up points to that I want to get to. But first, I want to talk about one of the debates that we've had in the space over the past few years, and it's where does value accrue? And one of your earliest posts, the Fat Protocol thesis, was one of the earliest kind of thesis in the space of value accrual. I'm curious what you've learned in the ensuing 5+ years since you wrote that post. That if you were to write that post today, what might you evolve, if at all, or what have we learned about where does value accrue?
That's an interesting one, because I think it still holds up, and I think the conclusion was right, but the reason why it was right was wrong. And so back when I wrote it, the basic idea was, and going back to the beginning, we were parting from that place of where's the data, and we were looking at the architecture of Web 2, where the data is held by companies, and the architecture of Web 3, where most of the data is held by open networks. And I took the view of, well, value accrues to wherever the data is. And if the data is in the protocol, in the base layer, then that's where value should accrue. And then when I was thinking about the mechanisms that allow for that to happen or that make that happen, I was mostly focused back then on the social dynamics of a community with tokens, where I think I described this feedback loop, where you have a base layer protocol or blockchain that, or any other kind of smart contract protocol or Web3 protocol that has a token and incentivizes the use or the development of the network through that token. So for instance, in Bitcoin, you have the Bitcoin network and the Bitcoin service. You have miners who provide the Bitcoin service in exchange for Bitcoin itself. And so that's their incentive. And then you have applications that are built on top of those protocols that help commercialize the protocols. And so, for example, Coinbase would be an example of an application built on top of several base layer networks, and helping commercialize them. And that would create a feedback loop, or at least that was the observation, where first, the incentives made it such that people would be willing to invest in the infrastructure and providing the service. And then that would allow for applications to be built on top. And then as those applications became successful, that would generate more interest in the underlying network and therefore the underlying token, which further increased the incentive and to both provide the service and create applications. And then you would have a feedback loop. And I would say that, that's kind of right, but it's a bit of a shallow way of thinking about it. And the basic idea was, well, if the data is in the protocol, then the application doesn't have that much defensibility necessarily, or at least it doesn't have the same kind of defensibility that applications in the kind of Web 2 era had. But I didn't really go much farther than that. A couple of years later, as I kind of kept thinking about it, and I wrote an update to that post called Thin Applications, kind of developing those ideas a bit further, I realized that, value accrual and value capture are different things. Or actually, this is one of the ways in which fat protocols can be misinterpreted, where value accrual is an ongoing process of where value is going, and value captured is where value is stored. And in the fat protocols thesis, I was mostly focused on where is the value stored over the long term, but it didn't really make an assumption about whether the value would go only to the protocols or only to the applications. But it did make the assumption that as the protocol grew and the network grew, that the protocol would be more valuable than all of the applications. And so that can be taken to mean that the applications are worthless and don't have any value. And that's clearly wrong. Picking up the example of Coinbase again, it's the largest public company in the space. It's clearly an incredibly successful investment. And an incredibly successful company, and it sits at the application layer. So it's not like we can say that the application layer doesn't accrue any value. However, if you take the value of Coinbase and you compare it to the value of all the underlying networks combined, then you see that effect where the value of all the protocols on top of which Coinbase operates is far greater than the value of Coinbase itself. But it doesn't mean that Coinbase isn't a good investment. It doesn't mean that Coinbase doesn't accrue any value. And so the revision that I would make is that in the fat protocols era, I was thinking mostly on a single protocol at the base layer, one protocol, one application. And the more correct way of thinking about it is, or one protocol, many applications. The more correct way of thinking about it is, especially now as the multi-chain world has developed and we have a lot more information about how applications are built, is that we have a lot more of that multi-chain world where you have multiple applications consuming multiple protocols. And so you have to evaluate the total value of all the underlying protocols in relation to any individual application. And then the application can have a business model and operate more like a traditional company, but rent or consume services from a variety of underlying protocols. And that doesn't look very dissimilar from the API world. The difference is that, Coinbase is not consuming, it's consuming a bunch of Web2 APIs, but it's fundamentally consuming the protocols of Bitcoin, Ethereum, Solana, and all of the different networks that they support.
That's well said. And I want to go deeper on the smart contract platform wars that some people have called, right? Like we've seen Ethereum, we've seen, you just mentioned Solana. You've invested in other ones. There are plenty of others that have tried to compete in different ways, and they've had different sort of approaches. So, I'm curious, what do you think? Well, first off, is it winner take most, or how do you think it's that's gonna play out?
Mm-hmm.
And two, what do you we've seen different approaches. I'm curious what you think we've learned, or what's your hypothesis on what are the attributes of the winner?
Yeah. Going back to the original placeholder thesis, one of the analogies that we used to describe networks were as nations, especially the base layer networks. And I think this applies the most to the smart contract networks. And I quite like that analogy because if you think of what a smart contract network is, say like Ethereum or Solana or the many others that exist, they do a lot of the same things fundamentally that a state does. when it comes specifically to the enforcement of contracts, where you could argue that at the end of the day, one of the key core functions of the state in the kind of physical world that we inhabit is enforcing the contracts between the constituents of that state. So if you and I have an agreement and we write it in a legal contract, we are bound by that agreement. If I break the agreement, then your recourse is the state, essentially. And on chain, we have smart contracts, which are code, and they don't rely on these kind of traditional expensive courts or negative incentives or disincentives to break the law in order to work, but they're just kind of ruthlessly and automatically executed by the underlying chain. And so then you can kind of imagine all the efficiencies that creates, and the inefficiencies of the kind of paper legal system. Now, when you have a network that's processing and running all these contracts and you're relying on that network to properly enforce them, especially if you're going to trust it, then the underlying governance of that network is extremely important to you. And so if you have, and this is very similar to how we evaluate countries today, one of the main ways of evaluating the economic stability and reliability of any nation is we look at things like the stability of its political system, the stability of its court system, the stability of its legal system. And those countries which have elements of corruption at any of those layers do worse than the countries that have solid legal systems, solid justice systems, and so on and so forth. And so one of the reasons the US has been one of the most prosperous places to do business in is because of the trust in its legal system. And so when we take those concepts and bring them to the Web3 world, when you're evaluating different smart contract networks, you're thinking about many of the same things if you're choosing to do business in any of them. You're thinking about the underlying consensus mechanism, which is essentially the underlying governance system. You're thinking about who has control over the network, if at all. You're basically thinking about the relative sovereignty of this network. And I have an old blog post about this called, I think it's called Sovereign Crypto Networks, that explores the different elements of sovereignty that add up to what we might say is a sovereignty score for an underlying chain. And they have things to do with, or the elements are things to do with, how decentralized is the supply side, like the miner base, for example. And then it also looks at, well, what is the governance system of the underlying chain? What are the applications built on top? Are they built by a broad base of community members, or are they built by a single company or team? And so you can look at all those elements, and one way to kind of consolidate it is just you're thinking about how centralized or decentralized it is at various levels of analysis. And the most sovereign networks are the ones who are most decentralized at the most levels of analysis. And so when it comes to the smart contract wars, there's competition on functionality and performance. And that's kind of the first layer of competition. And so we have some differentiation in sort of the development environments, for example. So a smart contract written for Solana is written in a completely different way than a smart contract written for Ethereum. But we also have some interesting co-opetition going on where a lot of Ethereum challengers or competitors are using the same virtual machine, the same kind of code execution environment as Ethereum, called the EVM. And those examples are actually quite interesting because at the surface level, it can appear that they offer exactly the same service because you can write a smart contract, say in the Solidity language, which is for the Ethereum virtual machine, and you can deploy that smart contract or that software in any chain that also uses the Ethereum virtual machine. And so there you have, let's call it feature parity. And then what they compete on are things like, well, how fast is it? And so scalability has been one of the main conversations over the past couple of years, because when there's a lot of activity going on through Ethereum, for example, it can get really slow or really expensive. And so some smart contract networks try to compete on that basis. And that is a fruitful or like a valid vector for competition in the short to medium term. But I think thinking very long term, we have to assume that all chains reach some level of feature parity and kind of similar levels of performance. And so that variance between performance and scalability and those kind of technical things between networks should disappear over time. And that's due to just different kinds of technological innovations. And so Ethereum is scaling in a couple of ways. It's moving to proof of stake. And it's also allowing for a community or a layer, or let's call it layer two is what's called, of networks sitting on top of Ethereum that help make it faster. Things like Polygon and CK Sync, et cetera. And so at the end of the day, if you assume that the functionality is going to be roughly the same, and you assume that the performance is going to be roughly the same, you're forced to look underneath and consider, okay, how are the underlying protocols governed, and how much can I trust the underlying system? And so that's where we're going to see a lot of differentiation, where some chains are, for example, married to the idea of proof of work. And I would put Bitcoin in that category, where one of the key differentiators for Bitcoin and one of the ways it seeks to keep itself differentiated is by adhering to the principle of proof of work, which is a very expensive but very secure way of managing a decentralized ledger or a blockchain. But it creates a bunch of side effects, like the way it consumes energy and things like that some people really care a lot about. But then you have things like Ethereum, which started as proof of work and then is migrating to proof of stake, I think sometime this year. And that's a big governance shift. It's a little bit like going from democracy to another system. That's not quite the right analogy, because you could argue that proof of stake is more democratic. But just as a brief summary, in case someone's not too familiar with these terms, in proof of work, you have the machines kind of doing the work. You have you scale the network by scaling the number of machines that provide the service. In proof of stake, you can have a much more efficient network with a smaller footprint, because the decision about which machines get to do the work is based on how much of the underlying asset they own. So you could think of that as actually a very political decision. How does the network arrive at consensus about its smart contract? And so the merge, which is the moment where Ethereum is going to move from proof of work to proof of stake, is going to be a really interesting case study precisely in that question of how do networks differentiate and create value over the long term. Because some people really don't like the idea of proof of stake. They have a philosophical disagreement with the concept of proof of stake. And so those people are going to choose not to build on Ethereum 2.0 because it is proof of stake based. Other people quite like proof of stake, and they will continue, or they will build on a proof of stake network. And then you have people who really only want to build on top of proof of work. And so they're looking at things like building on top of Bitcoin, maybe using a network like Stacks or Lightning. And they will never build on top of a proof of stake network because they don't believe in it. But even within, say, the realm of proof of stake, you have differences between communities in terms of even the political systems of the networks. And so if you take a more kind of modern comparison, say, between Ethereum and Solana, there you have, differences in development environment and things like that. Solana is way faster than Ethereum in a practical way. However, it's considered to be far more centralized than Ethereum in the way the network is run. And so some people don't really care about that centralization, and maybe even trust the development team of Solana to kind of keep things running the way they are. And they're happy to trade away decentralization in favor of speed. But plenty of other people would much prefer to have a slower and more expensive blockchain that is more secure and less vulnerable to centralization risk. And so to answer your question more concretely, I think there's room for maybe 4, maybe 6 really large smart contract networks that will be enormously valuable. I didn't come up with that number using a formula or a calculation, but mostly looking at how industries outside of crypto tend to consolidate. And they usually tend to consolidate around 3 to 6 major players that control the lion's share of the market. And they have relatively little differentiation between them other than values and governance and maybe some technical differences. But fundamentally, there will be differences between the communities and between the belief systems. And then I think we'll have a longer tail of also smart contract networks, but that may be more specialized and more focused on specific areas. So it's not hard for me to imagine that, and actually we're starting to see examples of this, that a particular kind of service, for example, let's take decentralized exchanges, that could get spun off into its own chain, and it could be a smaller kind of network that is interoperable with all the big networks, but that is purpose-built for a particular kind of offering. And so I think the long tail will be made up by kind of specific function chains and networks, maybe even some geographic networks as well, where you might have national blockchain networks that have certain rules or have to comply with certain rules and regulations of a state, or maybe regional networks that are focused on a particular geography. But for the most part, I think the differentiation at the kind of short end of the tail, those 4 to 6 major blockchains, is mostly going to be philosophical.
Yeah, that's really interesting. And you maybe alluded to it, but do you already have a sense for what those major philosophical disputes are going to are going to be? Have they already formed? Or
I have no idea what the disputes of the future are going to be. I'm sure they're going to be extremely interesting. So far, I would say the major debates have been, well, maybe even going way back to Bitcoin. The block size debate was a big philosophical debate, and some people even called it a civil war. And the block size debate was a governance decision in the Bitcoin network around essentially how many transactions you could fit in a block. But the difference, or the challenge was that if you increase the block size, then it increases the resource needs for miners, which actually can cause the network to centralize more, because you need more and more expensive hardware to produce larger blocks. And so people who wanted to scale Bitcoin by increasing the block size were battling against people who didn't want to increase the block size because it would lead to more centralization. And so that was a huge political debate and decision, and highly controversial. And the answer ended up being somewhere in between. There were some small optimizations made to the core Bitcoin network, but the block size was basically left untouched. And then you have other things being built on top of Bitcoin that help make up those gaps. On the kind of Ethereum and competitor side, most of it is, as we covered, just the different levels of centralization, the supply side fundamentally. And people also battle around the different developer environments. So, for example, some people really hate Solidity and the Ethereum virtual machine. One developer we talked to said that developing on Solidity was like eating glass, and they much rather develop on something else that wasn't quite as painful. I think those are kind of short-term, quirks and effects. So ultimately, languages and platforms evolve, but that does become a base for differentiation. And then I think over time, it really does come down to community, because if you grew up with Ethereum, for example, it's much harder for you to switch to another network. And part of it might be a philosophical decision, but another part of it might just be that's what you're used to. Some people only buy Toyotas. Some people only buy BMWs because it's what they know. And, you could say that cars are functionally equivalent to some level, and they're mostly competing on, little things on top. And that may be the case for blockchains as well. But one way in which I think this is going to resolve is you get to feature parity in terms of functionality. You get to some level of parity in terms of performance. You get to some level of parity in terms of what services are offered on top of all of these networks, because they all have decentralized exchanges, they all have tokens, they all have all these functions, they all have DAOs, NFTs, etc. And then it'll have to come down to just how strong and resilient the community is. And so that's why I focus a lot on governance and community. And that's what leads us to DAOs and organizations and the rules of these organizations, et cetera.
Totally. The bear case I've heard for Ethereum is that it's trying to do too much, that it's trying to be, World War III proof or sound money, but it's never going to be as sound as Bitcoin. But it's also trying to be the best platform for developers. Of course, the bull case is that it is the best community, or most developers or head start. What do you think about that bear case?
I think it's quite valid, and those are the risks. And we're not we're portfolio investors, and so we have investments in a variety of networks, including Ethereum, including networks that are challenging Ethereum, and that comes from kind of the pragmatic view that different people have different preferences, and so it's not. I don't think the outcome here is a God chain that governs everything and runs everything. And I actually think that's quite unhealthy for a market. You do want to have 4 to 6 major players with kind of fundamental differentiation that can battle each other and compete with each other. And that's the best outcome for everyone involved. And, the move to proof of stake is controversial for many reasons, but it will also put Ethereum on a path to be more similar to the networks that are challenging in terms of both scalability and, well, I guess performance is related to scalability, but it will cost them some constituents. I would say that what Ethereum has going for it is sort of what you mentioned with the community. What's different about Ethereum is that it's trying to be a lot of things at once, but it's not because say Vitalik wants it to be a lot of things at once. It's rather because you have a diverse community of builders on top of Ethereum taking it in different directions. And I would say that that's a subtle difference from, say, a chain that is more centrally managed. Like, for example, I would qualify, and some people might disagree with it. I would qualify Solana as being more centrally managed than Ethereum. And we're investors in Solana and we support that network as well. And so we don't see this as a negative. We just see these as differences. Those if a network being managed by a central team had a tendency to want to be everything, that could be more concerning than a network that is more decentrally managed. But that could also be a good thing. I honestly don't know, because people were having these kinds of debates with, for example, Android and iOS, and it's actually hard to tell who won, whether Android won or iOS won, because, for example, iOS is clearly a much better business, but there's a lot more fun phones running Android around the world than there are iPhones, and so I think it'll end up looking a bit like that, where the differences are going to be kind of similar to just the differences between people choosing iPhone versus iOS versus something else. Sorry, Android versus iOS or something else.
Yeah, that's a good analogy. One thing that you've said throughout the years in terms of something that defines some of your thinking is this idea that capital is control. And it's interesting. We've learned a lot about governance or seen a lot of experiments in the last few years. And there have been some people who've said, hey, maybe decentralizing ownership is more effective than decentralizing governance, completely, in the sense that, hey, we're trying to thread the needle between making people feel included, getting building the community by getting buy-in, and getting people excited, while also being able to effectively make decisions. And so I'm curious what you think, what you've learned, what you think the space has learned over the past few years of seeing all these experiments in governance.
So first, I don't think you can separate governance from control. I think governance from ownership. They're fundamentally the same thing. When you own something, you control it. And so, I do think it's helpful to change the words we use. And so governance can be quite broad and confusing, and it's a very loaded term. And so it is actually easier to talk about ownership. It's something that it's easier for most people to kind of understand and process rather than governance. And so I do agree that we ought to be using the term ownership more than governance for most cases. But they're one and the same.
Yeah, I guess, but I meant
yeah.
sort of economic upside from control, from ownership, I guess, then, to use your province.
Right. And so, maybe to talk a little bit about that relationship between governance and control and ownership and its relationship to economic upside. The idea is that you have an organization that manages economic resources, say a company or a DAO, and then the capital of that organization is really or the capital structure of that organization is really the ownership structure. And so from the kind of venture world, we understand that very well. We ask for a cap table and what we get is the list of owners. But not everyone on the cap table is making all of the decisions around the company. That would be crazy. If you had to ask every shareholder of a company to have an input in every decision, that clearly doesn't work. And a lot of the early mistakes in DAOs, I think, have to do with trying to approximate that. And so a lot of the philosophies and a lot of the ideologies have to do with the elimination of hierarchies, the flattening of organizations, which are quite noble, but in practice are very difficult to make work. And where the space has been trending is actually getting closer to how corporate organizations function, where DAOs are starting to create hierarchies and create teams and groups and figure out these ways of delegating certain decisions to certain people as opposed to having everyone have an input on it. And this is something that our governance researcher, Mario, explains in a blog post that I think is called Uninstitutional Isomorphism. If you search institutional isomorphism on the Placeholder website, that would probably show up. And so he describes that tendency for essentially DAOs to start looking more and more like traditional organizations. And I think it's because they're running onto the very same problems that cost us to set up organizations the way they're set up today. However, you can have both things. You can have a digital organization that is owned by a lot of people, but where most of the decisions are made by designated, delegated, essentially equivalents of executives. And that's not too different from the way it works in traditional private equity. VCs aren't making design decisions on the product of the companies they're invested in. They're more operating at the board level. And actually the most important decision that the investors in a company make is actually, should the manager still be the manager? Should the leader still remain? And so the board exists as a way to evaluate and judge, say, the CEO, but the board allows the CEO to make the decisions. And so I think DAOs are battling with the same challenges. And I think it'll end up in a similar way where token holders will ultimately decide on major things, major changes to the underlying protocol, or major changes in core teams or management, or major changes in how the treasury is governed, but less and less focused on like the smaller decisions that so many DAOs are trying to do.
That is well said. Maybe gearing towards closing here, what else do you think we've just learned via the DAO experiment in terms of how we've seen what types of things they work well for, what types of things they don't work well for? What are you excited for future applications we haven't yet seen? And maybe also just gearing towards closing, one thing I'll ask is like, a lot of Web3 sort of happens in cycles, and we had sort of DeFi summer, we had the NFT. I think we had excitement of DAOs, we had play to earn, various different L1s. Like when you look forward as to what could be the next sort of thing that pops off, it's like whether it be decentralized social or I don't know, consumer or some other thing. Like where are you most excited going forward, or trying to spend some time or look at a lot of projects?
Yeah. So in terms of DAOs, where I'm spending most of my kind of recent thinking time on is on the debate of let's call it the legal personhood of DAOs. And I kind of like to think about it asking a provocative question, which is, are DAOs people? And that can seem like a strange question, but we decided that companies were people in the legal system, and for very specific reasons. And what's been one of the kind of, I'm not sure if we should call it a lesson, but one of the hot topics of conversations in DAO land are whether DAOs should be wrapped in a legal entity that's managed by a state, or whether they should remain sovereign on-chain entities. And that's actually quite a difficult question, because on the one hand, DAOs are natively digital, smart contract-based organizations that can do lots of things. But in and of themselves, they don't have an interface with the traditional physical legal system. And so that creates challenges around, for example, if you want the DAO to own property, if you want the DAO to enter into legal contracts, not smart contracts, with other entities or other persons that may be required to operate under traditional laws, then that might create the need for DAOs to have some associated legal incorporated entity. And so many DAOs are heading in that direction. I think some DAOs are going to need it and benefit from it. And so, for example, I'm quite interested in DAOs who do wrap themselves in a legal entity. Well, those DAOs, what they also get, they get the superpowers, let's call them, of a traditional legal system where they can own property. And so it's interesting to think of a DAO owning a building, for example, but also they get the privileges that the state can grant organizations, specifically limited liability. And that's something that people are really attracted to. However, I do think that the largest, most valuable, most impactful DAOs are going to be unwrapped, completely sovereign, independent DAOs. And they won't have the same rights and the same obligations as the wrapped DAOs, which at that point, they might as well just be companies that are managed by smart contracts more than DAOs in and of themselves. And the reason I believe that is because even though I think there will be some very large kind of incorporated DAOs that will kind of focus on things that require that incorporation, I think they'll run into the same kind of glass ceiling when it comes to scaling and decentralizing as traditional companies do. And so it doesn't actually allow the DAO to take advantage of the full power of the underlying chain. So for example, if you take an LLC in the United States, you have a maximum of how many members you can have in an LLC. I believe the number is 99. And so if you wrap a DAO in an LLC, you can only have 99 members. And so you can't have a massively decentralized global organization running on smart contracts that is also wrapped in a legal entity. What that's going to do is it costs the DAO its sovereignty. And so it's a little bit like doing a deal with the devil. When you wrap a DAO in an entity, you're gaining some really important powers, but you're also giving up something really fundamental, which is the sovereignty of the organization. Now, on the other hand, completely sovereign DAOs are also choosing to almost completely isolate themselves from the traditional legal system. And so, they won't be able to do things like own property or enter into the same kinds of contracts that a wrapped DAO would. But it would be able to massively decentralize itself, have thousands or even millions of stakeholders all over the world. And it's my bet that those organizations are probably going to turn out to be the most valuable ones. But again, it doesn't mean that there's not going to be any value in the wrapped DAOs, but it's mostly, a fascination in terms of, or my personal fascination in terms of how these different kinds of DAOs are going to emerge and coexist. So I'm, I haven't resolved those questions, but I'm kind of leaning towards the fully decentralized on-chain digital DAOs as the ones that innovate the most. And then going forward, there's a lot of things that are emerging, as you mentioned. There's things like decentralized social networks and new protocols that are coming to market that are going beyond, say, decentralized finance, which was really most of the market from the kind of 2019, 2020, and 2021 era. I do think that the core component of decentralized social, and let's call it decentralized media in general, including social media and all kinds of human to human interactions, I think the core of that is really NFTs. And obviously NFTs have had a phenomenal rise over the last 12 to 18 months. And a lot of it is speculative. It reminds us a lot of the ICO boom of 2017, where most of it was useless. And so most NFTs are useless. But coming off of the ICO boom, we had all these amazing protocols and communities and layers of infrastructure that were built. And so we're starting to see essentially a similar cycle play out with NFTs, where they had their kind of speculative rush and boom over the last year, and a lot of that has disappeared. But it has left behind a series of ideas and concepts and communities that I think are going to come up with some really interesting use cases and products. And I think at the end of the day, NFTs are really about identity. And I've been trying to wrap my head around this idea that, NFTs are by most people probably still considered things like art or, media or music and ownership over those things. And that may be the case, but I think NFTs say a lot more about the person that holds them than they do about anything else, really. And so it's interesting to think that your digital identity in the Web3 metaverse is the combination of your wallet addresses, your on-chain history, everything that you've done with those wallet addresses, and the assets and the objects that you've collected as you've kind of moved around the Web3 metaverse. And so, it's interesting to think that you might be able to tell a lot about a pseudonymous address purely by looking at its NFT portfolio. So for example, I may not know you. I don't need to know your name, but if I can see that you have a CryptoPunk, I can actually assume a lot of things about you. And if you have a Bored Ape, I can also assume a lot of things about you that are very different from the assumptions I would make if you had a CryptoPunk. And so if you take that idea and just extrapolate it to eventually users just collecting thousands and thousands of NFTs as they kind of navigate the web, putting all of those data points together might actually allow us to build a really complete picture of who a user is without necessarily violating that user's privacy. And so that's very different from how it works on the web, where we have companies like Google and Facebook that, for all we know everything about you in a way that's very privacy invasive. It could be that NFTs are what allow us to have similar levels of insight into who a person is, which is what allows us to customize services, create custom feeds and things like that, but without violating their privacy. So NFTs as bits of information about the person who hold them, I think it's quite a big idea.
I think that's a great place to wrap, Joel. Joel, for people who want to go deeper into Placeholder and your work, where can you point them, or any other upcoming plugs our audience should be aware of?
No plugs, but our website is up at placeholder.vc, and so a lot of our research and writing ends up there, and all of our investments and things like that. So that would be the place. I'm not active on social media, but my partner Chris is quite active on Twitter, and so often he'll tweet more of the kind of things that we're discussing and thinking about in real time. And so what ends up on the website is kind of our long-term thinking work, and following Chris in social media will give you kind of the real-time view into what we're talking about. He also tweets about surf, and so that's that's part of it. But the non-surf crypto tweets are probably the best way of staying up to date on our latest thinking.
Totally. And you guys also have a great blog, and Joel's been on other podcasts, including this one, and they've been great. So if you enjoyed this, I highly recommend checking that stuff out. Joel, thanks so much for coming to the podcast.
Thank you, Erik. Appreciate it.
If you're an early stage entrepreneur, we'd love to hear from you. Check us out at villageglobal.vc.